When I was little, my father was famous. He was the greatest samurai in the empire.
Hey everybody, Jerry Williams, aka Greater Sapien here. Thanks for stopping by. The other day I made a video taking apart the flawed claims of a video by Kryptonite Physics, mirrored by Taboo Conspiracy. I only discussed about the first 80% of the video because, honestly, that's how far I got through it before I started writing a script about all the errors I had seen. But on a flight home from Vegas, I thought maybe I should deal with the last part of the video just to tie a bow on the whole thing and deal with those who might want to claim that I was purposely avoiding a portion out of fear or some such nonsense. In the original video I debunked, there was a small section that said this.
Let's look at relative motion and inertial reference frames. The Kryptonite Physics video, and this sheet, ends, inertial reference frames. If A is different to C, and it is, how can A change when it's put in a carriage with wheels on? It cannot. As
it turns out, this was a summary of a longer video that claims to disprove relative motion and inertial reference frame physics. So I'll go over that here. Okay, in their video, Kryptonite Physics walks through a few scenarios in an attempt to build evidence toward their conclusion.
This one sheet explains all you need to know to try and debunk the Kryptonite Physics. At the top, for the fish bowls, A and B, it is the same experience. As bowl A is within an inertial reference frame, it is the same as B being on the ground. Astrophysics and the heliocentric model rely on this physics.
Okay, I'll stop there. They start with two fish bowls and ask if they are experiencing the same movement, and say, yes, just as I would. Crypto says, since A is in an inertial reference frame, it is the same as B, which is true. And the reason it is because B is also an inertial reference frame. I don't think they understand that. But I don't want to dive into inertial reference frames right now. Let's just deal with the scenarios as they present them. Now, as I started to write up this script, I reached out to Kryptonite Physics to clarify why these moving people were placed in the scenarios. Here's the response. The problem with this setup is having something else in the scenarios moving doesn't change what motion is occurring, but it does change what is seen. Let me explain. Since the two bowls both have a constant rate of motion, V1 and 0, they both feel as if they are not moving. But what they are seeing is very different since Crypto put those people in there. A sees the person nearest to it as moving away at its walking pace. If A can see the outside of the box, it will see B as moving toward it at V1, and the person nearest B as moving toward it at the rate of V1 plus the walking pace. If A cannot observe outside of the box, then it feels no motion itself and perceives only the person walking away from it. B, on the other hand, sees the person near it as moving closer at the walking pace, A as getting closer at V1, and the person near A as closing the distance at a rate of V1 plus walking pace. Unless the box isn't there for B to observe, in that case, B only perceives the person approaching at a walking pace. So I'm already frustrated by this setup because placing these people in here complicates what constitutes the experience. I agree that the sense of movement experienced by the two fish bowls is the same, but having these people in the scenarios moving about adds unrelated information. And that's just a tip for future videos if you want to make them, Chris. For the second section, Crypto places insects on the wheels in different scenarios and asks about their motion. By the way, I'm calling them insects even though Crypto calls them bees. I was writing this up and I kept having to say the B at A and the B at C and the B at B, and it was annoying. So insects, just insects. Let's let Crypto explain first.
The bottom section, we are first asking what is the difference for the B on wheel A and C. on C, it is just rotating. The B is at a constant velocity, under a constant force. For the B in wheel A, we refer to known physics. Wheel rolling without slipping, or rigid body rotation with translation physics. See the video linked below. The velocity of the B, on A, is the sum of both vectors, v1 and t1, for any point on its rotation. The B is at an ever-changing rate of velocity, in an ever-changing direction. A constantly changing rate of acceleration. We have now confirmed, with known physics, that the experience for the B on wheel A and C are different. If you think differently, you are denying known science.
Stop there. They say, with wheel C, the insect is under a constant velocity under a constant force. They say with wheel A, the insect is under an ever-changing rate of velocity in an ever-changing direction. And in addition, they say the insect at A is under a constantly changing rate of acceleration. They think merely stating their conclusion makes it a fact, and say if you disagree, you are denying known science. The problem is they don't know science, and thus they got a number of things wrong here. First, they say the insect at wheel C is under a constant velocity under a constant force. The constant force part is true, but the velocity part is not. Velocity is a rate of speed plus a direction. It is a vector. Crypto even gave it a little vector arrow in the diagram, so they should know this. The rate of speed for the insect on the wheel is constant, but since it is on a spinning wheel, its direction is constantly changing, which means its velocity is constantly changing, which means, by definition, it is accelerating. The insect on wheel C is accelerating at a constant rate. That is why it is under a constant force, because of its centripetal acceleration. The insect at wheel A is also at an ever-changing rate of velocity due to its ever-changing direction, as Crypto properly noted, but it is not under an ever-changing acceleration, just constant acceleration, the same as wheel C, which I will show in a moment. I do, however, want to point out a bit of something that's irritated me about Crypto's approach here. They noted the force that the insect at C is under and not its acceleration, while they mentioned the acceleration that the insect at A is under and not the force. A word of advice for anyone making these types of videos. If you want people to compare the attributes of different scenarios, you have to mention the same attributes in all the scenarios. If you don't, it looks like you're trying to hide something or that you don't know what you're talking about. So let's compare the acceleration these two insects are undergoing. Let's give some value to these wheels. I'm going to change the values to meters per second because that's how my brain thinks when it comes to these things. So instead of 7 miles per hour, I'll call these 7 meters per second. First, let's compare some easy values to calculate. At the top of its wheel, insect A has a velocity of 14 meters per second. That's the tangential velocity in the center of the wheel plus the velocity of the wheel itself.
The velocity of the B, on A, is the sum of both vectors, v1 and t1, for any point on its rotation.
Half a rotation later, at the bottom of the wheel, the point touching the ground, that insect is stationary. That's the tangential velocity, which is pointing in the other direction. So that's a minus 7 meters per second. Added to the velocity of the wheel itself, 7 meters per second, that's a total of 0. That means in half a rotation, its velocity has changed by minus 14 meters per second. What's the acceleration of the insect at wheel C? Well, at the top of its wheel, its velocity is 7 meters per second, which, by the way, is the tangential velocity at that point on the wheel plus the velocity of the wheel, which just happens to be 0. Half a rotation later, at the bottom of the wheel, its velocity is minus 7 meters per second because the vector is pointing in the opposite direction. That's a change of minus 14 meters per second in half a rotation. That's the exact same change in velocity as wheel A. In other words, that's the exact same acceleration as wheel A. Let's try some more complicated ones just for the S and Gs. Let's go from the 45-degree spot to the 90-degree spot, or an eighth of a rotation, and we'll compare the vectors. Here are the velocity rates at these two spots on each wheel. I got these values using vector addition, like Crypto was so proud of in the other video. As you can see, the tangential velocity added to the wheel velocity results in different velocity vectors at the 2 points on the different wheels. That's to be expected. But when we calculate the change in velocity through vector subtraction, the change in velocity, the resultant vector, is the same for both wheels. The insects are experiencing the same acceleration. They are experiencing the same motion. Crypto's assessments of C and A are incorrect. But let's move on and see what they propose next.
We now move to the B in the carriage, on wheel B. The experience for the B is the same as on wheel A. It still has the two velocities acting on it. Putting it in a carriage changes nothing for the B. The wheel is still rotating and moving, surrounded it with a carriage on wheels changes nothing.
Here, Crypto is correct. The experience of the insects on wheel A and wheel B are the same. I'm not sure what they're getting at with the carriage comments, though.
According to relative motion and inertial reference frames, the B should now have the same experience as being on C, just rotating.
Should now? I'm not sure what that means. Well, as I showed just a moment ago, the acceleration of the insect at wheel C is the same as A. And if C is equal to A and A is equal to B, then C is equal to B. That's the transitive property of equality. It's basic algebra, but I don't think you should need basic algebra to understand that reality. Now, when it comes to physics, I am very hesitant to say that some things should be obvious, but the acceleration in rigid body rotation with translation is pretty close to obvious when you lay it out in 2D like this. When you have a rigid body rotation, like wheel C, where is the acceleration coming from? What is causing the change in velocity? The rotation. If you now have rigid body rotation with translation, like with A and B, where is the acceleration coming from? What is causing the change in velocity? Is the translation causing the velocity change? No, the translation is a constant motion. The change in velocity is solely coming from the rotation, just like the rotating rigid body without translation. But I find it odd that they say, now that the cart is around it, relativity says B and C are the same. I have no idea where they're getting that from. Relativity says nothing about putting something in a container, somehow changing the physics of that thing.
The observer's position or velocity can not change what is happening to the B. You are just an observer, you don't change anything.
This is the first time they've mentioned an observer in this whole piece. Why have they brought up an observer now? In addition to the physics being demonstrably incorrect, this is why this is a bad video, because they introduce concepts as if they have significance, but they give no context for them, and they don't tie them to the attributes that are currently under discussion. Why are you bringing up an observer now? What does that have to do with anything? Crypto closes the body of the video with this challenge.
To debunk this, you can deny relative motion and inertial reference frames has anything to do with the heliocentric model. You can deny or ignore known physics, rigid body rotation with translation, and pretend it doesn't exist. Or you can explain how magically putting it in a carriage with wheels, or you standing next to it, changes anything.
I'm not going to do any of that. First off, I've shown through the math that this motion experienced by the insects in each wheel scenario is the same. So I'm not denying any of those things. I'm pointing out that the maker of that video, Chris UK, does not understand those concepts. They were introduced to the concepts of rigid body rotation and translation, learned a tiny little bit about it, and made a leap. It's probably said too often, but this is the perfect poster child for the Dunning-Kruger effect. Look, when I posted a link to my previous debunk video, they replied with a link to a series of videos by a physicist explaining rigid body rotation and translation motion and saying I should tell that physicist that I've debunked known physics. The problem for Crypto is that nowhere in that series does that physicist talk about the scenarios like wheels A, B, and C being different. He doesn't talk about anything like that at all. He just talks about how the vectors add up and how you can calculate the velocities at different points on the wheel. That's all. Kryptonite Physics took that little bit and said, I'm going to make this claim over here now. They learned a new little thing and thought that they mastered the concepts in a couple weeks at a level beyond the thousands of people that have been studying relative motion for decades, for a century. They learned a little bit, and they think they're a master. And I'm not going to explain how magically putting a carriage with wheels or you standing next to it changes anything, because no one claims that. I've been a physics nerd for over 40 years. I've taken university courses. I've spoken directly to professional physicists about relative motion. And hell, I've read thousands of comments and posts and articles by mainstream physics proponents online and in libraries, and not once have I ever heard anyone make that claim. Chris, you are literally the first person I have ever heard that claim from. And I would argue about it, but I don't even know what the hell you mean. Now, I mentioned earlier that I reached out to Chris to clarify something about this video. And in one of their replies, they said that they think I will ignore all the physics mentioned and talk about the relative motion inertial reference frames. Well, I haven't had to argue for inertial reference frames yet. It just so happens that the math supports inertial reference frames. I do, however, find it odd that someone would make a video claiming to debunk inertial reference frames and then deride anyone who referred to them in their rebuttal. Crypto also said that I cannot show how the experience on wheel A for the insect is changed when on wheel B. In reality, impossible. The problem they have is no one has claimed the experience on wheel B is different. I say it's the same. I showed how the insect on wheel C was experiencing the same acceleration as the insect on wheel A before you even introduced the third wheel. So it had nothing to do with putting a cart around it or sticking a person next to it. It's just how physics works. Okay, I spent a couple minutes doing that last bit, and I think I now may have an idea of what Chris UK was thinking with the cart and the observer thing and the inertial reference frame and relativity. So now I'm going to talk about inertial reference frames, Chris. I've already shown your conclusions were wrong, and now I'll talk about inertial reference frames. When these topics are discussed, oftentimes the reference frame will be in a container of some type because the people discussing it want to remove the visual cues for the observers in the scenario. Here, if I were to say that the insect on wheel C is experiencing the same motion as wheel B, someone might say the insect would be able to see the landmarks moving by with wheel B, so I might propose that the wheel B is in a closed train car. This goes back to my criticism of crypto for putting these people in the scenarios. When we discuss these things, we can't help but put ourselves in the position of the observer in the frame of reference. And so we say things like, I would see the tree going by, and I'd know I was moving, or I would see that person walking. When we think of experiencing motion, we think of it in the context of the sounds and the visuals. So isolating objects in containers is solely to keep those discussing it from being distracted by what they think they would notice with their senses. But it's not the closed container that creates the inertial reference frame. Having uniform velocity creates it. All three of these scenarios are inertial reference frames, cart or no cart, because their velocity is constant. And when scientists speak of an observer, they aren't talking about a person. They are talking about the reference point the interactions are being observed from, not placing an actual observer in the scenario being observed. But I guess those will just have to be added to the list of things Chris just didn't understand. They didn't understand that the insect at wheel C was undergoing constant acceleration because in their mind, acceleration is only when speed changes, when in fact, when direction changes, acceleration is occurring as well. And because of that lack of understanding, Chris failed to grasp that while the insects are in have different velocities, their rate of change of velocity, and thus their acceleration, is the same. Those fundamental misunderstandings are the foundation you built this argument on, and since you got that all wrong, everything that follows from them is also wrong. Mathematically, provably, proven wrong. But it's not all bad, Chris. I'm sure you are far from the only person that has misconceptions about these things. I mean, sure, they're not hopping on the internet and claiming they've revolutionized a century of physics. That takes a unique type of ego. But it's provided an opportunity for them to learn from this by watching this video. So, thanks. And that's it for this video. Take care, everybody. Until the next one, peace.
That's my job! That's what I do! I don't lose! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.